Okay, we're in section 31.4 of the notes. This is the examples. I'll go through the examples. Hopefully you paid attention during lectures, and these examples will just confirm what was discussed in lectures. All right, so I'm going to go to the whiteboard, and I'll go through the problems one by one. If any computations become too difficult, I'll recommend that you use a computer algebra system or your calculator or your cell phone. But again, you need to learn technology. I realize not every teacher at Essex is indicating technology is important, but it really is. Your ability to use computational devices is going to bode well in life. All right, so the first thing up here, granted a picture's been given to me, but the part of it is just understanding what the picture is. So a couple of things over here. It says find the area bounded by, and they give, I'll outline this for you. They give these curves here. So one is a line, that's another line, that's a line, that's a line. So on an exam, what you'd be expected to do is you said, find the area that bounded area is, visualize the bounded area. So I'm going to go, one at a time. I'm going to graph, x equals 1 first. I want to graph this out. And what does that look like? Well, x equals 1, if I looked at that, would be a line that looks like this over here. That's x equals 1. And then if I were graphing out, the next guy, I want to point out, I'm going to graph this out and graph out things that are easy for me. What would that look like? Well, x equals 3 looks like this line over here. All right, what's the next one I'll probably do? I'd probably do y equals 0. And what does that look like? It looks like a line that looks like this over here. Now I want to point out, if I graph those 3 lines out, it really doesn't bound any area yet. There's a whole bunch of open spaces here. So the next line is going to be that, I'll circle it for you. It's going to be this one over here. And what does that look like? Well, that's a line whose y-intercept is 1 and has a slope of 2. So that looks like this over here. All right, part of the examples are going to be learning experiences. And what I notice over here is there is a bounded region now, and I can shade that bounded region in. And bounded means it's, this is bounded over here. I can't, there's a border on all 4 sides. They go on to say that this can be represented by an integral. All right, let's write that down over here for you. I want to point out what they're saying over here. I'll go through one thing at a time. This corresponds to a lower limit, and it says what x is. That's right here. This is an upper limit that says x is 3. All right. The next thing is the curve, and that's the curve over here. This is called an integrand. This over here is dx, which is the differential, which means we're moving along the x-axis. All right. So what I'm going to do now is I'm going to get the area of this, and it represented by that integral. So over here, if I look at this, 1 to 3, 2x plus 1 dx is that area. Well, to do that area, I'm going to point out, I'm going to divide into regions that are simple for me. And there's 2 of them. All right, so let's talk about this one first. And if I looked at that, the base of that, we're looking at it, it starts at 1, it goes to 3. So the base is equal to 2. What's the height of that? Well, 3 plus, now I'm going to do this thing, which is a triangle. What's triangle mean? 1/2 times the base. Well, the base is 1 to 3, so it's 2 units long. Now the height of it, a little more difficult, but the bottom line is we can get the height of this thing. Now, how do I do that? I want to point out, I'm going to put the points down for you. This point over here is 3, 3. This point over here is going to be 1, 3. And what's this point over here? Well, that's going to be 3, well, that's along the line. So if it's along the line, it would be 2 times 3, which is 6, plus 1, which is 7. But what's the height of that? It goes from 3 to 7. So the height of that would be 4 units. I'll write that down. What do you get over here? Let's write this down. 6 plus 4, which is equal to 10. So what is it going to be? 10 square units. Notice they got the answer over here, and they talk about dividing that region into 2 parts. One is a rectangle, the other one's a triangle. All right. This is a learning experience. I want to point out graphs are being provided, sort of help and speed up the process of what we're doing. All right. You should be able to construct those graphs on your own, by the way. Let's put the next one down. And the next one, I'm kind of reading it. It says, y equals 1 minus x squared. I want to point out, if I were to graph that out, what I start to realize over here is just before I even graph it out, that the y has to be greater than or equal to 0. It couldn't be otherwise. what I would do over here, I just try hard. So I just simply say y squared equals 1 minus x squared. Yes, I'm squaring both sides. So it's going to be x squared plus y squared is equal to 1. Now, what do I know this thing graphs out? As a circle, a unit circle centered at the origin. But here's the deal. I got to keep this in mind. So I need to erase something in this picture. What do I need to erase? I need to erase this part of it. All right. Let me put down this over here. This is -1 and this is 1. This is a rough picture. All right. We have a better picture provided to us. That's a, looking at, that's a semicircle. So I got that part graphed. Now I'm going to do x equals 0. Well, x equals 0 looks like this. This is x equals 0. I do not have a bounded area, by the way. The next thing, it says y equals 0. I'll put that down. I still don't have a bounded area. I'm sorry, excuse me. X equals 1. That's what I meant to say. And then y equals 0. And y equals 0 looks like this. Now I want to point out the 4 lines not lines, but curves. This one, this one, this one, and this one. Is there a bounded region? There is. And the bounded region is this thing over here. All right. So what they say is this is represented by this integration over here. Let's go through it. And I'll write this down for you. The integration is going to be from 0 to 1, 1 minus x squared dx. Let's go through this. I'm seeing the lower limit is 0. Let me point this out to you. This is x equals 0. I'm seeing the upper limit, x equals 1. I'm seeing this thing over here, the curve, and it's the area where the differential is dx. So along the x-axis, so they're talking about this area in here. Now, by the way, that's a tough integration to do, but the bottom line is looking at that picture. What do I know? It's 1/4 of the area of a unit circle. Well, the unit circle is going to be pi, r squared is going to be 1. What's it going to give me? Pi over 4. So the area represented by that picture is pi over 4. Again, I want to point out better picture provided for me and an answer is being provided for me. All right, number 3, more difficult, no doubt about it. It says for time t in hours. It goes on to say that a bug is crawling at a velocity v in meters per hour. They give me the function. They're going to give me a picture. You don't really need a picture. I want to point out why that is. You could draw your own picture over here. The understanding that this is going to be t and this is going to be v of t. And what does it look like? Well, it's from 0, and at 0, this would be 1. I'll put that down for you. So 0 would be 1. And then when you get to 1, where would you be at? You'd be at a half. So it looks like over here. So this would be 1 comma 1/2. And that's a rational problem. And I'm sure you've had a good deal of experience in Math 119 with that rational problem. So I'm going to say this is my picture. And I'm just going to do this over here, shade that. All right. So let's take a look at it. And, certainly when I'm reading these things, when I'm reading these things, if I understand what I've read, that's not a bad thing. All right. So what's the time? Time is in hours. So t is in hours. Whoops, sorry about that. So t is in hours. All right. What's v in? Well, I got to read it. V is in meters per hour. Whoops. Okay, let's read it. It says estimate the area represented by the shaded region. What is the unit of this area? Well, to do the unit of the area, and that's the first thing I want to talk about. I'm going to do like rectangles here, and we'll talk about that later. And if I'm looking at a rectangle of this thing, what's the base of that over there? The base would be in hours. The measure would be in hours. And what's the height of that? The height of that's in meters per hour. Right. So if you were to do the area of that, the area of that rectangle I'm putting over there would be, the unit would be hours on the bottom. And what's the unit on top? It would be meters per hour. What I notice about that, hours cancel off and I'm left off with meters. So the area here, which may sound strange to you, is in meters. All right. So I'm going to look at the picture, a better picture, because I want to estimate the area. And I'll be honest with you, my picture is not very good, but I could estimate the area looking at that picture. So I want to go to the better picture. I'm going to look over here. And, someone says, how would you estimate that area? Well, they give me a really detailed picture of it. This is a really detailed picture. I'm going to put the points down for you, though. This point over here is, looking at it is going to be 1. That's 1 hour. and that would be 1/2 meters per hour. So the thing is definitely slowing down, because over here at time equals 0, the bug's going 1 meter per hour. So the bug's slowing down. The question is, estimate that area. And that's many ways to do that. I'm not going to say one way is better than the other. Well, what I'm doing over here is I'm going to look at these little tiny squares here. And I'm going to talk about the area of one of those squares. So the area of one of these squares. And I'm going to say, looking at it, the base of it, of those little tiny squares over there, again, I'll put on what I'm doing. I'm counting it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the base of that is 1/20th of an hour. Now I want to point out over here, and again, I want to encourage the counting of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And the height of that is going to be 1/20th. I'll write that down for you. We're just doing the area of this little guy right over here. It's 1/20th, and that's going to be in meters per hour. So the area, that one little guy there, is going to be 1/400th of a meter. All right, that's not so bad. Here's my problem though, and I'm not asking you to do it. I'll do it for you. You count them up, and this would be a nice approximation. So someone says, I don't have the time to count it. I understand that. We have better ways of counting, but you'd count each of these guys over here one at a time, one at a time. Like here, you'd get, if I'm counting these things up, I'd get, just looking at it, I think we did this before. There's 20 of them there. There's 20 of them, 20 more there, yada, yada, yada. Where does counting become difficult? And I want to point out to you, the counting becomes difficult when they're not whole boxes. So that's where people might say, I disagree with your counting over here, but I had to take this one here and this one here, look at those two little boxes over there and say, looks like a half, looks like a half. I would say another box. But what I did is I counted all the boxes up. So I'm going to say the total number of boxes that I counted together, and I did count it. I'm going to say I counted, and it's going to seem strange to you, the total number of those little square boxes, these things over here, I counted 277.25 boxes. So then the question is, well, how much area do I have? Well, what are you going to do? Well, each box is worth 1/400th of a meter. So this is what each box is worth. That's each box. That's what it's worth. How do you get the area? Just multiply it. 277.25 boxes. Each box is worth 140 meters. By the way, I don't expect people to count that. However, for your entertainment value, see if someone else can count that. See if you can agree with me or maybe disagree. But I'm going to say if I did that and I did the arithmetic, I would get this number over here. How did I do that? I used a calculator. I did not do that by hand arithmetic. All right. So let's talk about the next one. I'm going to make an erasure for the next question. This question's been answered. And I'm going to say, roughly about 0.7 meters. The bug has traveled that distance in the hour. So I'm going to get my eraser out. I'm going to erase this nonsense over here. And I want to use the picture again. I'm going to reuse this picture over and over again. This one says use the delta T to be 0.5. Now, we're not trying to confuse you over here, but if this is, 1 unit long in the base, delta T 0.5 would be, I'll count it in, would be 10 units in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll do that. All right. I want to put the points down over here again for you. And this point over here is going to be what? Going to be 1, 1/2. What's this point over here? It would be 1/2. Again, they said the delta is 1/2. And what would I get over there? And again, if you can't remember, go back and I'll point out what I mean by that. The function's 1/1 plus t. So let me write this down. Vt is 1/1 plus t. Well, what would you get over here? On the bottom, you'd get 3/2. So this would be 2/3. let me remind you what I did. I took this thing, I plugged the half in. 1 plus a half is 3 halves. 1 divided by 3 halves is 2/3. Now, by the way, we're not trying to confuse you. We're trying to encourage you to read and understand what you've read. All right. Whoops, sorry about that. So what does it say? Estimate the distance traveled during this hour. Do both upper and lower estimates. So I'm going to put my rectangles in now because rectangles are really easy to do. I'm going to say something like this. Now, someone says, why did you do a rectangle like that? Because if I look at this over here, and I am going to erase this later, this would be a lower limit. A lower limit. It's an actual underestimation of the area. What's that going to be? The lower area is going to be 1/2. That's the base. What's the height of that? 2/3. We'll do the arithmetic later. Plus, what's the next guy going to be? 1/2's the base. And what's the height of that rectangle? 1/2. Let's write this down. We'll do the arithmetic and we'll check the K. It's going to be 2 over 6 plus 1/4. Mistakes happen. That's why we give you a K. The common denominator is going to be 12. Well, 2 times 6 is 12, so it's going to be 4. And 3 times 4 is 12. That's going to be 3. So it's going to be 7/12 meter. All right, let's go back over here. And I want to see if I've done that. And I noticed I got, well, I'll go to the next page. I'll do the upper limit now. What's the upper limit going to be? I'll put this one down. Let me get my eraser out first. I'm going to erase all this business over here. And yes, you can reuse these pictures as much as you like. So I'm going to put the upper limit in. Again, we'll look at the key later. I'm going to say that's the upper limit. So let me put the upper limit down now. Now, someone says, what do you mean upper limit? It's over the curve. It exceeds the value of it. So at upper limit, I'll write this down for you. Upper, whoops, upper. Oh, I did it again. Let me get my eraser out. It doesn't look right. Upper. Well, it's going to be 1/2. What's the base of that? Yeah, it's 1/2. What's the height of that? 1 unit. Plus, let's do the next rectangle. The base of it's 1/2. And what's the height of it? It's 1/2. So what'd you get over there? 1/2 plus 1/4. And what does that give me? Well, I get a 4. And then I get 2 plus 1, which is 3/4. All right. Let me go back over here. And I think I might have made a mistake somewhere. And I think I made a mistake in some of my arithmetic over here. Let me just go to the next page, see if they got 3/4 down. I got the 7/12, right? That's right here. But I'm wondering why I'm not seeing 3/4 there. I think I might have made a mistake. So 1/2 times the height is 1. And 1/2, oh, I see it now. I took the wrong value. Let me write that down. I'm going to correct it. This is a learning experience for me. I made a mistake. And let me point out where that mistake is. This is going to happen to you. I'm going to point it out to you. The base is 1/2. The height of this rectangle is 1 unit. The base of this is 1/2. But the height of it is not 1/2. It's going to be 2/3. My mistake. Let me do the arithmetic now. 1/2 plus 1/3. Common denominator is going to be 6. Well, it's going to be 3 plus 2, which is 5/6. That's right over here. All right. Let's keep going. And I'm going to have to reuse the diagram. But I don't want to have to keep writing things down, like, the rectangles and stuff. So I want to have a little better way of doing it. And I'm going to talk about it now. All right. So what I'm going to do is, one thing to do is recognize there's patterns in the problem. So I want to point out the patterns in the problem should be fairly easy to do if you can think what they're asking you to do. So I'm going to point out The delta t is 0.1 now. My goal is to be able to write this down, but not do the computation. I'm going to leave that to a calculator. So if you're doing a rectangle over here, I want to point out the rectangle for that thing over there, it starts at 0 and it moves over to 1/10. I'm going to do this thing over here, which is called, whoops, sorry about that, the left end point. I'm going to do the area of that rectangle over there. So I'm going to do area of left. I'm going to call it left endpoint. And what's that going to be? Well, it's tough. I'm not saying it's going to be easy for you, but left endpoint. So what's the first sample point going to be? Well, the base of every single rectangle will be 1/10. Every single rectangle is going to have a base length of 1/10. No matter what I take down, they're equally spaced, they're all 1/10. I got to worry about the heights. So I'm going to put this over here, V. And if I'm at the left endpoint, I'd be at 0. So let's go to the next one. The next one is going to look like this. And now the height's going to be that point over there. What would that be? It would be V of 1/10. Let me remind you what V is. V is a function, and it's 1 over, let me write that down a little better than that. V is a function of t, and it's 1 over 1 plus t. Again, my goal is to write a pattern down. What's the next one going to be? Well, if you keep moving over, you get another rectangle over there. I'm just moving over 1/10. And what would that be? Well, it would be, give me 1 second over here, V of 2/10. Now, by the way, I'm going to say yada, 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 but my big concern is, where do I stop? Well, I stop over here, right? Remember what this is. We're stopping at 1. But what's the left endpoint over here? Well, I have to back away from this. So what's this going to be? It's going to be 9/10. All right. I'm not asking you to compute this, but I want to write it down as a summation now. So it's going to be left endpoint. It's going to be 1/10 times the sum V. Well, I'm going to say that these things over here have something to do with 1/10. For example, this 0 is 0 times 1/10. What's this one? 1 times 1/10, 2 times 1/10. And what do you get? Up to 9 times 1/10. So let me write this down for you. Now I'm going to use a counter variable I. And where does I start? I starts at 1 and it goes up to 9. All right. Now, someone can say, what does this represent? Well, think about it. Going back to the picture, it represents a rectangle there that's above it. So this would be an upper estimate, upper. Now let's do the right endpoint. And again, we're trying to get you to think for that. And what's that going to be? Well, it's going to be A. You know what? I'm going to say this AL. This is a right 1/10. Well, let's take a look. Now we're at the right endpoint. So we're starting here. All right. I'm sorry. I made a mistake there. We're starting here. All right. So whatever that value is there. Well, you know what? I'm sorry. I made a mistake there because I'm not looking at my picture. It is this point here. So what's it going to be? Well, let's write this down. We're starting at the right one. We're not starting at 0. We're moving over a little bit. So V 1/10 plus, well, if you thought about the curve over here, you know, something's going to be over here now. It's going to be lower. It's not too important that I know that, but I'm going over 1/10 each time. So what's the next one going to be? 2/10 plus V of 3/10. These have really nice patterns, by the way. Yada, yada, yada. The trouble for a lot of students is knowing when to stop. All right, so where are we going to stop? We're stopping here. And it should be stopping at 1, right? So what's that going to be? 10/10. Let's write this down as a summation. 1/10 times the sum. Well, it's always going to be V of something. And it's going to be 1/10 times something. Let me write down the counter variable now. I equals, well, I'm going to say this starts at 1, then it goes to 2, then it goes to 3, all the way up to 10. So I equals 1, I up to 10, right? This is going to be an underestimate. All right, I'm not expecting you to do the computation, by the way. So I'm going to say over there, I did the computation for you, and I'm using a computer to do that. Everything is being written down for you, though, including the computation with exact values. Everything is being written down, again, including the computations and the value. All right, the exact value and approximate value. Let's go to the next one. And again, I'm building on a skill set. At first, I did 0.5, then 0.1. Now let's look at the next one going to be. Now, granted, I really can't draw this picture over here, but the problem about this one over here is I want to point out I'm still going to be doing these right and left endpoints. All right. So I'm going to put that down for you now. We're going to talk about the left endpoint. And I'll talk about AL. Well, the base of those things is 0.05. Well, let me write this down for you because I actually don't like decimals. So if T is 0.05, that would be 5 over 100 or 1 over 20. All right. So I'm going to say the base of every single rectangle is 1 over 20. Now, I want to point out what we're doing over here. We're taking a right endpoint. So we're doing this point over here. Whoops, sorry about that. So what's that going to be? That's going to be, we start at 0, right? That's going to be V of 0. What's the next one going to be? Well, I move over to take another sample point. What's that going to be? V of 1/20th. Then I keep moving over 1/20th at a time. What's the next one going to be? V of 2/20ths. No, do not simplify those. Yada, yada, yada. I'm going to eventually get to the end. This is where a lot of students say, I don't know what the end means. Well, we need to get to this last one over here, but we're still taking the left endpoint. All right. What's 1? It's 20 over 20. So what would this one be over there? That'll be 19 over 20. I'm going to write the sum down. And what's the sum going to look like? 1/20th times the sum I equals something. V, well, it has something to do with 1/20th. I'm going to put this down. I'm going to say some multiple of 1/20th. For example, that's 0 times 1/20th, 1 times 1/20th, 2 times 1/20th, up to 19. So I starts at 0 and it stops at 19. We're not asking you to do the computation at this point. We're asking you to write it down. Do I provide the computation? I do. All right. This will be a better estimate. Let's put down the right endpoint. By the way, this is going to be in this example over here, an overestimate. That's not always true, by the way, to know your pictures. Let's do the right endpoint. And we know from experience it's going to be an underestimate. Again, my goal is to write down the right endpoint now. Well, the base is still 1 over 20th. Where am I starting now? Not at 0. I move a little bit over. So I go V to the 1/20th, then V to the 2/20ths. You should notice a nice pattern to these problems over here. And that's typical if we take easy problems. That's going to be 3/20ths. Well, I'm going to say yada, yada, yada. The problem with that is a lot of students don't know when to stop. So we need to discuss it. Where are we stopping? We're stopping over here at the very last endpoint, the right endpoint. That would be 20 over 20, which of course is the number 1. We were expecting that. I do want to write it down as a sum. And you may wonder why that is. That's going to be our ultimate goal, to write things as sums. Whoops, that doesn't look like a sum, does it? So it's going to be V of something to do with 1/20th, right? Oh boy, I did a mistake again. 1/20th. I'm going to put the I over here. 1, 2, 3, up to 20. So I equals 1 up to 20. All right, we got that covered. Now someone says, well, you do the computation. How'd you do that? I used a machine to do it. I didn't do it by hand, by the way. That would be torture for me. But you may want to discuss, how would I do this on a machine? And you want to be able to do that on a machine. And we'll discuss that. All right. Now, by the way, they say as an aside that you can actually do the exact area of this over here, and it turns out to be the natural log of 2. Don't worry about that right now. What are you worried about? Can you set up these summations? All right, let's go to the next question. I put the Mathematica code down over here. I'll also talk about using Sage, but this is Mathematica. I'm also going to talk about using Sage later on. However, I'm going to repeat this over and over again. Under no circumstances are you obligated to use what I think is a good product. And I hope you go through life where people give you that opportunity, because later on, you're going to end up in either a school like NJIT where they mandate that you need to be using a product called MATLAB, which costs money. I'm not saying it's a bad product. What I'm saying is you need to develop the skill set where you're using products that you like to do. Hopefully you become an independent thinker and use products. Now, someone says, why do you use Sage? Sage is free. That's why I use it. I also was a big promoter at Mathematica at one time. I like Mathematica, but unfortunately what happened at the school was, and I know I told the story many times to you, students didn't use it, all right? And the school was paying for it. I was the only one at the school using it. So the school said, that's ridiculous. Why would we spend like 10 grand a year on a product that no one's using? All right. And, certainly I promoted it at the school. In my notes, there was examples of it down. But again, the bottom line, why did I come down to Sage? Well, the school's not spending any money on it. I'm spending a lot of time and resources on it. And, certainly I'm hoping you're paying attention to that, because one of the biggest complaints our students have when they transfer to NJIT is they feel that they're unprepared in the area of computer algebra systems, because the students at NJIT have a 2-year head start on you, where their teachers are using a computer algebra system. At Essex, I think I'm the only teacher at Essex that actually promotes a computer algebra system. Computer algebra system. And that's called CAS, by the way. All right, let's go to the next question. And this one says, and I'm getting better at this. And so someone says, what do you mean you're getting better at this? So it says over here, L6, R6, M6. Now, what happens a lot of times on exams, people start up the exams and really doing very little work. They often raise their little tiny arms up in the air and they say, teacher, what does L6 mean? What does R6 mean? What does M6 mean? What they're really communicating to me is absolutely no engagement of what's being covered in the course. All right. So there's no sense of shame about it. I would say that's kind of shameful if you show up to exam and you have not studied. That's shameful to me. All right. To me, it's actually a nightmare. But let me tell you what these letters mean. L6 means left endpoint 6 equal partitions. What does R6 mean to me? Right endpoint 6 equal partitions. What does M6 mean? Midpoint 6 equal partitions. We're going to do one at a time. But the first thing I want to do is I want to visualize what this problem is about. So what do they give me? I'll write this down for you. They give me f of x. I want to visualize. It's going to be 4x plus 1. No, you don't have to visualize. X is going to be on an interval. That interval is between 0 and 3. And I got to keep going. So what I'm going to do is I'm going to try to visualize this. And not that I'm great at it, but I know they started at 0. And I know they stopped at 3. And I know there's a line there. I'm not really interested in drawing a great line, but it's a line, y-intercept of 1 and a slope of 4. So maybe something like this over here. I'm kind of exaggerated it. I'm going to look at the area of that. That's a rectangle. That's a triangle. So let me put down some points over here. This would be 0, 1. What's this point over here? 3, 1. That's not bad. I think I can do that. What's this point over here? 3, well, it's on the line. So that'll be 12 plus 1, 13. We'll look at the key later, by the way. I want to do the exact area because I can. We'll put the other ones down later. I see a rectangle. That's this area here. Well, that's going to be base will be 3, height will be 1. Then I'm going to do this guy over here. What's that going to be? Plus 1/2. Base is 3. What's the height of that? Well, let's see. It goes from up to 13 down to 1. So that's 12, isn't it? Let's put our area down in this exact area. We'll check with the key later. 3 plus 18 equals 21. Hope I didn't make a mistake. Let's take a look. It's got the exact area. Exact area is right over here. We did it right. We got 21. Now, of course, what I need to do is I need to discuss these R6, L6, and M6. I'm going to do one at a time. And what I'm going to claim over here is the length of the interval is 3 units, and we're dividing it into 6 equal pieces. So 3 divided by 6 is 1/2. What I'm going to do is going to write this down for you. I'm starting at 0, and I'm moving up 1/2. Let's write this down for you. 0, 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. Now, someone says, why'd you count in halves and not reduce? Well, the length of the interval is 1/2. So I want to point this out to you. If you look at this, this is a half up, half up, half up, half up, half up, half up. All right. What's the base of every single rectangle? 1/2. Okay, let's write this down. I got to write it down. The base is 1/2 in every one of these examples. I want to do right endpoint. What does that mean? I'm moving over to this thing first. So what's that going to be? F of 1/2 plus F of, I move up to the next one, 2 halves. How many rectangles are we going to get? 6 of them. Let's keep moving over. F of 3 halves. F of 4 halves. F of 5 halves. F of 6 halves. All right. Now, before I go on, I want to count this for you. This is the base, and these are the heights of every single rectangle. There should be 6. 1, 2, 3, 4, 5, 6. I want to write this down as a sum as well. I'm not going to do the computation, but you can if you like. What do you get? 1/2 times the sum F of, well, you know what? They're going up by halves, right? So I'm going to say 1/2 of an I, and the I is going to start at 1 and end at 6. All right, I'm not going to do the computation, but I do it in my notes for you. Now we're going to do left endpoints. So what do you get? F of, well, I'm starting here now. 0, that's the left side, plus, I'm going to move up 1/2. I'm going to move up 1/2. I'm going to move up 1/2. Well, I'm sorry, I'm saying move 1/2, not moving, I'm just staying at 1/2. So I'm sorry about that. 2 halves, 3 halves. I'm daydreaming, by the way. F of 4 halves and F of 5 halves. Exactly where I expected to stop. Let's write down the sum. What's that going to look like? 1/2 sum F of 1/2 I starts at 0 and stops at 5. All right, midpoint's a little more tricky, and I want to point out why it's tricky. A lot of people look at this and they have a tough time computing the midpoint. But each interval that I'm on is going to have an endpoint. Let me get my eraser out. And yes, it's more difficult. I know that. By the way, there's all kinds of techniques. So we got left endpoint, right endpoint, and midpoint. And when you take Calc 2, there's going to be other points to consider. But let's do midpoints. All right. So someone can say, how would you possibly do that? Well, I'm going to look at these two over here first. Let me get my eraser out. And what's the first midpoint going to be? Let's see, what's the midpoint between 0 and 1/2? Well, you add the two numbers together and divide through by 2, right? So what would that give you? 0 plus 1/2 is 1/2. If I divide by 2, it's 1/4, right? By the way, this is going to have a very nice counting problem as well. I'm going to do this midpoint now. How do you do? Add them together. That would be 3 halves divided by 2. So that's 3/4. Again, this is going to have a nice pattern. Well, that's 5 halves divided by 2. You get 5/4. I want to point out what the pattern is over here though. And by the way, pattern recognition is really what we're looking for you to be able to do. So if you look at that, everything is in terms of quarters, right? And what are these things going? They're going up by 2 quarters, which I expected because the length of the interval is a half. So 1, 3, that's up by 2, 5. What would the next one be? 7 quarters. If you want, you can still compute that by looking at that over there. What's the next one going to be? 9 quarters. Again, if you want to compute that, you can get 9 quarters there. And what's the next one going to be? 11 quarters. All right. What are those things? They're the sample points. So let's write this down. F of 1 quarter plus F of 3 quarters plus F of 5 quarters plus F of 7 quarters. You'll see we get 6 of these. F of 9 quarters and F of 11 quarters. All right, I'm going to write down a sum for this one over here. Well, the base is still a half. This is more difficult, I know that. And it's going to be F of, I got to be honest with you, it's something to do with quarters, doesn't it? This is more difficult than something you did in Math 120. I know it has something to do with 2. And why is that? It's going up by 2. So I'm going to say 2i. And of course, then I got to really think about this. It's not 2i over 4 because that'll be I over 2, and that's not right. So I'm looking at it's got to go up by 2, and it's got to start at 1. So I'm going to do this over here. I'm going to say I equals 0. And what would that mean? I want 1 quarter at first, right? And what would do that for me? If I did I is 0, this would have to be plus 1. Let me see if that works though. All right, so if I do 1, again, if you did 0, you get a quarter. If I did 1, I get 3 quarters. That worked. If I did 2, I'd get 5 quarters. But where do I want to stop at 11? So what number would make that 11? 5. If you prefer, you can write this down a little differently. You could write this way. And by the way, don't feel obligated to write anything in any particular way, but I can write it down as 2i minus 1 for I equals 1 to 6. Let me go through that with you. So if I start at 1, this would be 2 minus 1 is a quarter. If I go to 2, this is going to be 4 minus 1, which is 3 quarters. And if I stop at 6, what would you get? 12 minus 1, which is 11 quarters. So I got 2 ways of writing it down. Now here's my problem over here. Someone says, do I need to compute that? Yeah, you need to compute it. All right, why is that? Can you compute? All right, so what are you going to be doing over here? You're going to see if you can get those numbers. Can you get these numbers that were given you? For example, can you get this number, L6? Can you get this number, R6? Can you get the midpoint number, which is 21? And can you get this number, which we did compute? All right, let's look at number 5. And number 5, again, yeah, I'm going to say it looks a little complicated to me. All right, so I'm going to read it to you. It says, find the area bounded by this thing over here. And it says, between -1. And I'm getting a little better at this. And what I mean by that is I'm looking at this picture over here. I'll write it down for you. It's the picture f of x. I'll point out what that means. X squared minus 2x plus 2. This is the f of x in the problem, that parabola. And again, I'm just roughly drawing that in over there. This is the parabola f of x. All right. They say, you're starting at -1. Well, that's that line over there. It says you're stopping at 3. That's that line over there. And they say y is 0. That's a line over there. And then I hope you realize there's an area over here. Now, before I do that, I want to, it's a rough picture, but I think I can get an idea that there's points everywhere that I could look at. And I'm looking at these points over here and one at a time. And it's kind of a crappy looking picture. There's no doubt about what I've done to this. So this point over here is going to be 3, 0. What's this point over here? Well, that looks like -1, 0. What's this point over here? What's along the parabola? It's going to be 3, let's see, 9 minus 6. 9 minus 6 is 3, and 3 plus 2 is 5. All right. So, maybe I'm not doing a great job at drawing it. That looks pretty good. What's this point over here? Well, it's at -1, right? So what'd you get? Again, plugging into the parabola. That's going to be minus 1 square, which is 1, plus 2, which is 3 and 3. Oh, 5. Look at that. Oops, sorry about that. So someone could say, could you estimate the area? And I think I can. And for me to do it, there's a variety of ways. I'm not saying this is the best way of doing it, but I want to get the vertex over here. All right. And what's the vertex going to, minus b would be 2 over 2, which is 1. So the vertex is at 1. I'm using my math technique, use 100. And what would 1 give you? Well, I got to think about it. It's on the parabola. So it's going to be 1 minus 2, which is minus 1 plus 2, which is 1. So 1, 1. By the way, the picture's pretty good. So what I would do over here, and I'll point out what I would do to estimate this area. And again, part of it is laziness. I do this, and I do these 2 triangles here. All right. And let me just shade them in with a different color. So it's a lazy way to estimate. It's not a good estimate, by the way. It's going to be way too big. All right, but I'm estimating it. Someone could say, I can do better than that. I can divide it into, 4 pieces when you're only doing 3. Someone says, well, I can up beyond that. I could do 8 pieces, and that's going to be better than the guy that did 4 pieces. Then someone could say, I could do 16 pieces. And before you know it, we keep up in the game to get better and better estimates. But I'm just looking for like a low ballpark estimate of it. So I want to do that, and I'll point out what I'm doing over here, and I'll shade it in for you. I want to do this thing over here now. And I got to do it. And what's that going to be? Well, it looks like 3, 4. The base is 4. And what's the height of that 1? Now what I'm going to do is I'm going to do this rectangle here. I'm sorry, triangle. I don't enjoy doing this, by the way. I got the picture all messed up now. So what's that going to be? 1/2. What's the base of that? Well, I'm at 1 going to 3. So the base would be 2. What's the height of that? Well, I'm going from 1 to 5, right? So that'll be 4. Plus, I'm going to do the next guy. And I want to do this guy over here. And again, it's an overestimate. It's much bigger than the actual curve. But what's the base of that? It's 1/2. I'm sorry, 1/2. The base of it is going to be what? Well, 1 to minus 2. Look at that. And what's the height of that? Well, 1 to 5. It's 4 again. Wow, they're both the same, aren't they? So let's do our estimate. This is my estimate. I'm using 3 pieces. You would get 4 plus 4 plus 4, which is equal to 12. That's an estimate. What am I estimating the area? Now, if you look at my notes, by the way, I'll go to the next page. I did trapezoids. All right, I did 4 of them, and I got an estimate of 10. All right, now remember, my estimate over here used 3 objects, which are triangles. They did something better. They used 4 trapezoids, and they got something, well, clearly smaller would be a better estimate. My estimate's way too big, by the way. But I'll be honest with you, their estimate using trapezoids was 10. Now, I want to say that the actual area is actually 9 1/3. So when I did 3, 3 approximated regions, I got 12. The next guy came along, he did 4, he got 10. But they say the actual area is 9 1/3. So both their estimates are overestimates, all right? So it says evaluate the Riemann sum right endpoint. All right, so I'm going to put this down for you. And I just want to set it up. I don't want to do the computation. And so the computation is really tough. So where does it start? -1, and it goes off to 3. And what are we doing? 16 equal pieces. So 16 equal pieces. What's the length of that? 4. Now we're doing right endpoint. So I'll write this down for you. It's going to be f of, well, right endpoint, what am I doing? I'm starting at -1, but I'm moving over a little bit. How much am I moving over? I'm moving over each time 4/16. What's 4/16? It's 1/4. What's the next one going to be? Well, if I thought about it, I'm just going to move over another quarter. What's that going to be? 1/4 times 2. yada, yada, yada. I got to get to the end. And this is the tough part. F of -1, and the end is over here, by the way, plus 1/4 times 16. I want to make sure that's right, by the way. And what do you mean by right? It doesn't give me the number 3. It certainly does. So I'm ready to write my sum down now. And this is going to be R16. What's R16? 1/4 times the sum I equals 1 to 16 F of -1 plus 1/4 I. By the way, I'm not going to do the computation for you because it really does require a computer, but I write this stuff down over here for you. All right. What's the next one going to be? Evaluate. It's a little bit more difficult. I want to be honest with you why it's more difficult. It's an arbitrary n now. N goes towards infinity. So what I do over there, I'm going to do n now. And I got a good example over here of how to do that. Rn. What's it going to be? Well, let's write that down. It's going to be, let's see, what do we get over here? It's going to be, there's 4 units, right? And I'm dividing it into n equal parts. And let's write this over here. And what do I do over here? And again, if you have experience with the finite, you'll have experience with the infinite as well. There's a bridge between the two. What do I get over there? Well, I get 4 over n. And then what do I get? Plus f of -1 plus 4 over n times 2 plus f of, well, you know what? I'll just put my ... down now. I'm not going to go for that. That's pretty easy to do. Let me erase this over here. Plus ... I want to get to the end. What's that going to be? -1 plus 4 over n times n. There's n partitions, by the way. So what do I get over there? I got a nice sum formula. I'll write this down for you. So 4 over n times the sum. I'm sorry, not n. I don't want to use n. I equals 1 to n f of -1 plus 4 over n I. All right. Here comes the tough part. And I do mean it's tough. A lot of students find it very difficult to do. So what do I got to do? I'll go through it with you. But I want to point out the first thing you got to do is you have to do this over here. We just did that. All right. I point out what we just did. We did 4 over n, and I got that f of -1 plus 4 over ni. The next thing you have to do, and it's going to be painful. I'm not going to say it's not going to be painful. You got to do the function evaluated there. So I'm going to write that down for you. F of -1 plus 4i over n. And what is that? I have to square it. So it's going to be that thing squared. I know this is tough, by the way. Minus twice that thing. Plus 2. My claim, if you do that, and I do want to encourage you to try to do that and match this over here, you'll get 64 I squared over n cubed. I'm sorry, you wouldn't get n cubed. I'm sorry. Got to erase that. N squared minus 64i over n plus 20. All right. If you took that, I'll write this down over here, and you took this and wrote, you know what? I'm sorry, I have to correct myself. And I'm going to say this is 4 over n. Sorry about that. And this would be, let me put that down for you. And I really apologize for not being more clear about that, because I want to make sure that you have to do this computation over here. Sorry about that. I should put the n cubed down now. N cubed, n squared, and n. You'll get that. And what is that? That's me simplifying this thing over here. All right, now here comes the next problem. Here's the problem. You're writing down these things over here, and you should know a couple of formulas. Like you should know that I equals 1 to n of I squared. You should basically know that you can use a sum formula for that. So all I did over here is I used the sum formulas for that. You should also know the sum formula for this one over here. That's written over there. And then the sum formula for a constant, which is, 20 would be 20 times n. The n cancels out because it's over here. You manipulate this guy. You eventually get down to this thing over here. And then what do? This is Rn. This is going to take work to get there. A lot of students don't put that time in to get that. But here's the deal. If you can't get that, I know it's a lot of work for you. If you can't get that, come see me and I'll go through every step on it. Then what do? You got to do the limit. Let me make sure they're going to do that. Oh, they didn't do, I'm sorry. The limit is n goes to infinity and of Rn. And what would that give me? 28/3. What is that going to give you? 3 goes into 28, 9 times and 1/3. As we said, that's the area. Now, if we had to do this for every single integral, it would kill us. It really would kill us. All right. But that section's done. What's the worst thing about this for a lot of students? This manipulation over here. All right. It's tough, though. I know that. We want you to try, though. We really do. Thank you for paying attention.